let a function f be defined by f of x is equal to 5 if x less than or is equal to 2, and ax plus b if 2 less than x less than 10, and 21 if x greater than or is equal to 10. Suppose this function is given to be continuous. F is given to be continuous. F is given to be continuous. Then what about A and what about B? That is, we have to find the values of A and B here so that the function f becomes continuous. So you can see that what is happening here, since f is given to be continuous, f is given to be continuous, f is given to be continuous. So you can have it is continuous at every point. In particular, f is continuous at x equal to 2 and at x equal to 10. So when f is continuous, when a function is continuous at x equal to 2, what do you mean by that? That is, left hand limit should be equal to right hand limit should be equal to value of the function at that point, isn't it? So we can utilize that here. That is, limit as x tends to 2 minus, that is left hand limit of fx, that is equal to right hand limit, limit x tends to 2 plus f of x, and that is equal to f of 2 here. And now what about x tends to 2 minus means, x tends to 2 minus means x is less than 2. When x is less than 2, what is the value of the function? That you can see that when x is less than 2, what is the value of the function? That you can see value of the function is 5. So you can have limit x tends to 2 minus 5, that is equal to limit x tends to 2 plus. When x tends to 2 plus means it is coming here, that is x plus b. So you can have that is x plus b, that is equal to f of 2. f of 2 means you can see when x equal to 2, that is 5 again. So you can have 5. That is limit of a constant, that is that constant only, that is equal, and this is a polynomial. So polynomial, then we have to find a limit. So we know polynomial is continuous, therefore direct substitution will do, that is value of the polynomial will be the answer. So that is 2a plus b, and again is equal to 5, we don't want, so that is 5 is equal to 2a plus b. So we got one equation connecting a and b. Similarly, again we know the function is f is continuous at x equal to 10. What do you mean by this? That is, when a function is continuous at x equal to 10, you know that is the left hand limit is equal to right hand limit is equal to f of 10, value of the function at x equal to 10. That is limit x tends to 10 minus f of x. What is f of x then? You can see that is when x less than 10, less than 10 means it falls here, so that is x plus b. So you can have x plus b there. And right hand limit means x tends to 10 plus means greater than 10. When x is greater than 10, you can see that is 21, so you can have 21, and f of 10, that is when x equal to 10, again the value is 21. So we have another relation like this, that is when x tends to 10 minus x plus b. X plus b is a polynomial, and polynomial is continuous. Therefore, instead of finding the limit value, we can have the functional value, that is 10a plus b. So that is the left hand limit. And then what about right hand limit? Being a constant, that is same again 21, we don't want it, so that is like this. So we have second equation. So we have two equations. The first equation was 5 equal to 2a plus b. So we can write it 2a plus b. So 2a plus b is equal to 5. That was our first equation. This is our second equation. Then using these two equations, we can solve for a is equal to, you just subtract these equations, you know, then 8a is equal to 21 minus, that is 16. 21 minus 5 is 16, so which implies a is equal to 2. And substituting this value in any of the equation, for example, if you substitute here, that is 2 into 2, that is 4 plus b is equal to 5, therefore b is equal to 1. So we have a is equal to 2 and b is equal to 1, then only the given function is continuous. Let us consider the graph of the given function. Now there are two bricks on the graph, therefore it is not continuous at present. But by adjusting the a value like this, or by adjusting the b value, we can change the position of these portions of the graph like this. Now you see, when b is becoming 1, the graph is changing, but it is not continuous. Now we change a like this, then finally what is happening, you see, when a is equal to 2, all the three pieces got connected and there is no break at all, so the function becomes a continuous. So when a is equal to 2 and b is equal to 1, the function becomes continuous. Now let us solve another problem. What is the value of k so that the function f defined by fx is equal to k cos x divided by pi minus 2x when x not equal to pi by 2 and is equal to 3 when x equal to pi by 2 is given to be continuous. So here the function is given to be continuous. We have to find the value of k. So again, we have the value of the function is continuous, means it is continuous at a very point. So in particular it is continuous at x equal to pi by 2 also. Function is given to be continuous. So it is continuous at a very point. So it is continuous at x equal to pi by 2. It is f is continuous at x equal to pi by 2. What do you mean by that? That is, limit x tends to pi by 2, fx should be equal to f of pi by 2. And then what is f of pi by 2? That is very clear. When x equal to pi by 2, functional value, that is value of the function, that is 3. Then we have to find the limit of this one. So when x, that is limit of fx means k cos x divided by pi minus 2x, x tends to pi by 2. Then how to evaluate it? For that we shall have a substitution. So what is the substitution we can have? So x is approximately equal to pi by 2. So we can put x equal to pi by 2 plus h. So as x tends to pi by 2, then h becomes a 0. Therefore, we can write limit h tends to 0, k cos, instead of x, we shall write pi by 2 plus h divided by pi minus 2 into x. X means pi by 2 plus h, like this. Then we have to simplify it. So that is, we have limit h tends to 0. So you can see that when cos pi by 2 plus h. What is cos pi by 2 plus h? So that is minus sin h, that you can see, minus sin h, and k you can take it outside, otherwise you keep there, no problem. So we can keep it outside. Then divided by, here you just simplify, that is pi minus 2h. So you can have minus 2h. So this minus and this minus getting cancelled, this 2 also you can take outside. Then what is happening? So that is equal to k into limit h tends to 0 sin h by h. 2 also outside. So k by 2 outside, then limit of sin h by h. So you know that is k by 2, because this limit is 1 only. This limit is 1 only. So we have limit value is equal to k by 2 and functional value was 3 at x equal to pi by 2. Which implies k is equal to 6. So when k is equal to 6, the given function will be continuous. Let us consider the graph of f given by fx is equal to k cos x by pi minus 2x. At present, the blue colored curve is having a break at x equal to pi by 2. A point is missing. Actually, at x equal to pi by 2, the fx value is 3. That is that blue point that is above the blue colored curve. So, at the present, the function is discontinuous. But by adjusting the k value, now you see when I am changing k is equal to 3, 3.2, 3.4, etc. What is happening? The curve is going up and finally the break gets filled. The gap gets filled. That is now you see when k is equal to 6, there is no break on the blue colored curve. So it becomes continuous. So when k is equal to 6, you can see that the function becomes continuous. Now let us consider a function f defined by f of x is equal to sin x by x when x not equal to 0 and 1 when x equal to 0. To show that f is continuous. To show that f is continuous. So when x, let us c be a negative real number. Let us c be a negative real number. Then definitely f of c is equal to the value of the function at x equal to c is nothing but that is sin c by c, that we know. And for limit also we can find in the same way, that is limit x tends to c, that is sin x by x, that is equal to we can have limit of x tends to c sin x divided by limit x tends to c then x, like this. Then we can have the limit that is sin c divided by c. So which exists because c not equal to 0, that is guaranteed because here c is a negative real number. In the same way we can proceed with c when it is a positive real number. So that is simple. So only the thing here is whether it is continuous at x equal to 0, there we have to be cautious. So that is when x equal to 0, then what is the value of function, that is f0, that is given to be 1 in the question, that is given to be 1 as per the definition of the function. Then what about the limit of fx as x tends to 0, that is equal to limit x tends to 0 sin x by x. What is it? We know it is 1. Let us have a visualization and come back. Let us consider the graph of sin x by x. When x tends to 0 both from left hand side and right hand side, what is happening to fx value? It is tending to 1. That is when x tends to 0 both from left hand side and right hand side. Then in either case fx becomes 1. So we can speak of limit of sin x by x as x tends to 0 equals 1. Okay, thus from the visualization also we could realize that limit sin x by x as x tends to 0 is 1. Thus we have the value of the function equals limit as x tends to 0 fx here. Therefore function is continuous at 0 also. F is continuous at 0 also.